Hey, what's up everyone? In this video, I'm going to be going over step-by-step how to complete Project 7. So the first thing you should do is navigate to your electronic music notebook and then select the Projects tab and then Project 7. So we have a link to MusiCode v12 here, and then we have a project description outlining some of the requirements. And then we have a Project 7 example here, which I'm going to go through in this video. So go ahead and click on Example Project 7. This is going to download the Jupyter Notebook to your computer. So once this is downloaded to your computer, then go to MusiCode v12, go to My Projects, and then go to your cloned version of MusiCode. If you haven't cloned MusiCode yet, then there's a video that walks you through that called Getting Started with MusiCode, so go watch that if you haven't cloned it. So we click that, and then to upload the example project Jupyter Notebook to this project, we can go up to Upload from Computer, and then you can either drag and drop the example project, or you can do Choose Files and then navigate to the file that way. Click I trust the contents and then click Done. Alright, so this is going to load everything into your notebook. So I already have mine pulled up, so I'm just going to jump over here. So I thought I'd start by just playing you the examples. So we have a more basic example for the first one, and then we have a full song, which is closer to what your project will be. But I'll just play you both examples now. So alright, so it's pretty basic, but you get the idea. And then here is the full minute-and-a-half project.
Levitate. 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 Levitate.
Alright, so there you have it. Shout out Kendrick Lamar for the sweet vocal sample. And yeah, so I'm just going to walk you through both of these examples line by line. Every line of code, I'm just going to explain what it's doing. Alright, so let's start here from the very top. So this cell of code should be at the top of every MusiCode session that you ever do. Okay, so the important thing is, one, we have to install sound file, and this is going to allow us to work with WAV files. Next, we have to import MusiCode v12, And MusiCode v12 is actually coming from here. So we can see MusiCode v12.py. And so this is the actual library of code which we're pulling all of these methods and attributes from. So the very last one in setup code is to initialize MusiCode and set the BPM. And so you'll notice M appearing in a lot of the code. So this is calling MusiCode to generate a waveform. And so these things should always be done at the very beginning. Okay, so next is going to be just a little outline of what we need. So we need drums, bass, chords, melody, and then we'll work with some samples as well. So your project needs to be at least 1.5 minutes. And so let's go ahead and get started with example 1. So this is a little bit more basic example just to show you the fundamentals of everything we're doing. Okay, so I'm going to zoom in a little bit here. Okay, so the very first line of code here, m.setBPM. So this is another way to set the BPM, right? So we have this method, which is initializing, which we always do at the beginning, but you can also use this m.setBPM at any point in your code. And so you have access to all BPMs. So you can take an idea, play it at 60 beats per minute, and then shift it to 150 beats per minute just by changing this number. All right, so we have 3 items in the drums. So first we have a kick. And so we can see here that we're loading a kick sample. We're going to time edit it to make it a quarter note, and then we're going to loop it 8 times, right? So to see this line, we have a variable named kick, and then we're using the m.sample method to load the sample into a wave. And so there's a few aspects to this sample function which I really recommend you go look at the lesson in MusiCode, which goes into detail how to use the sample. But I'm just going to give you a brief overlook. So the first element we have is a category. And so it would be helpful for you also to see this. So if we go to our MusiCode directory, and then we click on MusiCode files, and then samples. So these are all of our sound categories for the sample library. So if I want to access a kick in my project, I use the keyword kick. And then you can see here we're using the keyword clap. Here we're using the keyword hi-hat. And so whatever the name of this is, we just use that to call which sound category we want. And then here we can either pass a file name or we can pass a number. So let me show you the number way first. So I'm just going to create a new cell here to demonstrate this. So I'm going to click m.kick. So when I run m.kick, this is going to show me all of the kick samples that I have in my library. So if I were to change this line of code to 0, what this is going to do is it's going to retrieve the kick folder, which has these files in it, and it's going to grab the 0 item, which means the first item. So in this case, it would grab the virtual riot kick, right? So we're able to index the list using numbers, right? So keep that in mind. I kind of know which samples I want to use, and so I tend to just put the file name in there, but you can do it either way. Okay, so moving on this line, we have, we load our sample in, and then we're going to do a time edit. And so the time edit is going to be in relative rhythms. So in MusiCode before, we worked in seconds. So in the old version of MusiCode, this would have equaled 0.25 seconds. But now we're working with relative rhythms. And so this value, the quarter note value, will change depending on the BPM. Because think of, a quarter note at 60 beats per minute is much different than a quarter note at 280 beats per minute. And so now we're able to just adjust the BPM and then use relative rhythms instead of having to think in terms of absolute seconds. Okay, so we make this kick a quarter note, and then we're going to loop that 8 times. And this is going to create a 4 on the floor kick pulse. So just a basic quarter note kick pattern. Okay, so moving on to the clap. So the clap, we have a variable named clap. We're going to load our sample into memory like this. We're going to time edit it to make it a quarter note. And then we're just doing a slight volume increase, right? We're going to multiply the volume by 1.6, which is going to increase it 60%. So it's like making the volume 160%, Okay, so the next one is going to be the join waves. So in this, we are going to be taking a rest, which we can see right here, and we're going to join it together with this clap. Because if you think of kind of your standard kick snare patterns, they tend to have the clap or the snare on the 2 and the 4. And so we're going to wait a quarter note, and then we play our clap. Then we wait a quarter note, we play our clap. So this means that it's silent on the 1 and the 3, and then the clap will happen on the 2 and the 4. And so when creating rhythms with this system, you have to think deliberately about how much silence you need to add in to create the rhythm that you want. And so this one's kind of simpler because we just have one single rhythmic value, and then we're going to loop that 4 times. Okay, so the very last one in the drums is the hi-hat. And so we have our hi-hat, and then we're calling in this closed hi-hat. And then we're going to time edit it because we want to create an 8th note rhythm. And then we're going to loop this 16 times. I should point out that all of these, the hi-hat, the clap, and the kick, they all need to be the same duration, right? And so it can be kind of tricky to tell the duration of each of these because we're looping, we're time editing. And so there's a quick way to gauge this. So what we can do is we can say kick.time. And then we'll say clap.time, and then hi-hat.time. And so what this is going to do is it's going to print the duration of each of these samples in seconds. Let's go ahead and run that. Okay, so it's going to essentially print out in seconds the rhythmic timing of this. And so this is a very helpful debugging tool. I very much recommend using this. So we can see all of these are 4 seconds. So this means that everything adds up, everything's even. So that is a good sign. So I would really recommend if you're getting weird results from your add wave statements when you're trying to join everything together and add, combining the sounds, you definitely want to do this. This is very, very useful. Okay, so let's go ahead and just listen to the drums by themselves. So we can say drums.bounce. And then this is going to just give us a wave audio file preview of the drums. So there we go. Okay, cool. So one thing I want to point out that I sort of forgot to mention. So when you load this project, I would recommend starting by restart and run all. Restart and run all is going to load all of the code, reset your kernel so that you can begin to work with it. Keep in mind this project is really large, so it might take a minute or two for everything to load. But just keep that in mind. If you want to kind of build on this code, you're going to need to restart and run all. Okay. Okay, so we have a drum loop here. So let's go ahead and move on to our bass line. So I'm just going to get rid of that for now. Okay, so we have our bass line right here. So we're using a method called sequence. And so what sequence is going to do is it's going to take in a few different inputs. The first input is going to be a list. And so you can tell it's a list because of the square brackets surrounding it. And then each item in the list is a string. And it's going to be a label for the note that you want. So these are all sub-bass notes, so E0 and then F0. Cool. So it's going to play these in whatever order I define. So the second thing we want to pass in is the waveform shape. And so I added a few ways to work with this where you can actually combine multiple waveforms into one. So I'm using this sine tri blend, which is like a sine wave mixed with a triangle wave, which gives it a little bit more harmonics. Cool. The third thing we're going to input is the rhythm. So the rhythm is just going to be, the rhythmic value, what is the sequence doing? How quickly is it moving through the notes, right? So we have a 1/4 rhythm set, and then the duration is going to be 4 measures, right? And so we can go ahead and bounce this out just to hear what it sounds like. If you don't have a subwoofer in your computer, then you might not hear this super well, but if it were playing on a PK sound system, it would slap. Okay, so yeah, pretty much this is a basic sequence statement. Nothing fancy. We're just passing in a list of notes. We're passing in the waveform, rhythmic value, and then duration. Cool. Okay, so the next one, chord, or chords. This is going to be our chord progression, our harmonic content. So we have individual chords, which we're going to define here. And so we're going to be using the m.chord function, which is pretty cool because it actually has like every chord you can imagine just built into it. So we can say m.all chords, and it's going to return a list of all of the chords that you can use in this. And so, yeah, pretty much you just pass in this label, and all of the notes and the patterns of the chord are already programmed in, so you can just sort of have access to those without having to spell out each note. That can be time consuming, and not all of us have that stuff memorized, so we just program it into the computer, and then we can have access to it through the chords method. Okay, so we can see that we're using a minor 11 for this first one. I want to point out that the labels are set to be like MIN, and then major would be MAJ. So just keep that in mind that the labels are like specific, so just make sure you're using those. Okay, then we're passing in the root note. So we're building an E2 minor 11. So the whole chord will be started on this root note here. Then the third item we're passing in is the waveform type. And so I'm using a saw square blend to give a little bit more brightness. Okay, so here we're getting a little bit fancy. So what we're going to do is we're going to set this chord to be a quarter note, right? So we just have duration equals 1/4. And then we have this fade right here. And so a fade is designed to help you shape the volume of a sound. So this can be used to shape ADSR and really just give you control over amplitude. And so what I'm doing with this is I'm fading in a quarter note. So I have a quarter note value, and it's going to fade in like that. And so I'm actually going to, I'll just show you what this looks like. So we'll define chord 1 right there. and then I'm gonna get rid of that. So we can do chord 1 view. And so this is going to basically show us what one single chord looks like. And so we can see that there's this fade in, like that. And we can actually listen to that as well. So just to give it a little bit more dynamic, so it's not just the same, the same volume over and over, which can get kind of repetitive. So we're just going to, adjust the amplitude of these values just to create a little bit more interesting shape, Okay, so we essentially do the same settings here as we do right here. And so essentially we have like this uniform envelope that we're using for these chords. And so we have chord 1, which is a minor 11, then chord 2, which is a minor 9, right? And so this is defining each individual chord. Then the very last thing on this line is going to be the loop. And so we're just going to want to loop this 8 times because we want this chord to match up sort of with the melody. And so it's an important thing to remember that you want to have the chords and the melody sort of match up. Okay, so moving to this line here, we have a join waves statement. And so remember, join waves puts things horizontally on a timeline. So if I want to take chord 1 and then play chord 2 right after that, I'm going to need to use a join waves statement. If I were to use add waves instead, it would play both of the chords at the same time, and you would get like a minor 9, 11 AE polychord. So really be aware of which version of this you want to use, because join waves is horizontal and then add waves is vertical. So just make sure you remember that. So we just take chord 1 and chord 2, and so we're just joining those together, and then we're reducing the volume by about 30%. Cool. Okay, so moving on to this melody here. So the melody is going to use the sequence. And so sequence is, again, going to allow us to take a series of notes and play them with some rhythmic value. So here we have F sharp, D, A, E, and then we're using a 16th note rhythm right here. And then this is going to be a duration of 1 measure. And I'm using the fade in and fade out internally within the sequence method. And so what this allows you to do is shape the ADSR of each individual note in the sequence, right? So this can be very useful because the sequencer just tends to make everything the same volume. And so using these fade in parameters, you can really carve it and control the ADSR of each individual note in the melody. Cool. And again, there's a in-depth tutorial in MusiCode in the lessons that goes over how to use the fades. So definitely check that out. This is not a tutorial on how to do fades. We'll get there, but I just want to show you how it works kind of in context of a song. Okay, so the next one here is how we join these 2 different melodic aspects together, because we have this F sharp, D, A, E, and then we have D, F sharp, E, A. So we vary the pattern slightly so it's not too repetitive, and then we join these 2 different melodies together to create kind of a bigger, more varied pattern. So once we do that, we're going to then loop it 2 times, and then we're going to increase the volume by 70%. So now would be a good time to just draw your attention to one of the key features of how things are set up in MusiCode. So we're now working with object-oriented programming. And so every time we create a wave, such as this, we're able to apply certain operations to that, or certain methods to that. So let's just look at this as an example. So we have our melody, and we're joining it together, and then we're able to chain different methods on kind of one after the next, right? So we join everything together, and this is going to produce a waveform, and then we take that waveform that's produced by this, and then we're going to loop it 2 times. So then once we have the looped waveform, we're then going to increase the volume 1.7. So this is a way to chain methods together on a single line of code rather than having to write a new line of code for each method that you want to apply to it. And so this is a very common feature. You'll see this all over the place in this code. So just make sure that you're aware that that's going on. Okay, so the final aspect of this first example is going to be the mix 1, and then we have the add wave statement. So mix 1, this is where we sum everything together. We really want to verify that everything is the same length. We want to verify that everything is the right volume. This is where we put all the different elements together. So we're taking the drums track, the bass, the chords, and the melody, and we're adding it all together. Notice we're using add waves, not join waves. If we use join waves, it would play the drums, and then when the drums were finished, it would play the bass, and then when the bass was finished, it would play the chords. This is not what we're going for. We want all of them to be combined and play at the same time. And so in this context, we're going to use add waves. Cool. And then here we have the mix.